All right, let's do this. Hi, everyone. How you guys doing? My name is Aurélien Bombo. I'm very happy to be here, very excited. This is my first KubeCon. I made the trip all the way from Chicago. Not my first time in London, though, because I'm born and raised in Belgium, so not too far from here. Pretty familiar with London, kind of. Definitely not familiar with sunny London, so that's amazing. I work with the Confidential Containers project, where I help out with different aspects around the project, notably the CI. And then, lately I've been looking at storage. I also work with the Kata Containers project, where I serve on the architecture committee there, which is a group that, steers a project and has the final say on decisions. And then at Microsoft, my assignment really is the Linux Confidential Platform as part of the Azure Linux OS team. And so in the Confidential Containers project, we believe that confidential computing is the future of computing, right? Where people want to protect data not only at rest and in transit, but also in use, right? Protect that data from their cloud provider. So the thing is, when we talk about confidential computing, usually we focus a lot on the compute part, right? Not so much on networking or storage, right? And so today, I wanted to, share with you guys a little bit about what we've been working on with the confidential containers community, and so, to enable secure storage, right, and containers from a confidential standpoint. And so, mind you, a lot of this stuff is still very much a work in progress, but at least this will give you a good overview on the current state of things, right? And so with this, I'll talk about both the implementation itself, but also how that ties into the broader ecosystem so that we can deploy this at scale, right? And so I also have a PR that I'm working on in the confidential containers repo to enable all this, right? And so I'll share it at the end of this presentation if you guys want to take a look at it, right, and judge my code maybe. So the way that this presentation is going to unfold is that first I'm going to give some context on container runtimes, confidential computing, and how that works with Kubernetes. And then I'll split the presentation into two parts. First, ephemeral storage, and then we're going to build on top of that to detail a bit persistent storage, right? And then in between that, I have a demo based on the existing code, right? Based on that PR that I was mentioning a minute ago. So first and foremost, what is a confidential container? So typically when we think of containers, and this is not working, when we think containers, you think, Docker runc containers, right? Where you share the host kernel with the containers. Obviously, that's a pretty loose isolation, right? In terms of security, this is, we don't say that, we say this is not secure at all, right? Because you're essentially one kernel vulnerability away from having a container breakout where one of your containers, escapes this namespace isolation, right? And attacks the host or the other containers. Now, you can do better than this with Kata containers. And so in Kata containers, we use virtualization. We put the container inside a virtual machine, right? But you're still not protected against a potentially malicious host, right? Because imagine that you're an end user and you don't necessarily trust your cloud provider. Or imagine that you're a cloud provider and you want to enable multi-tenancy. You want to be able to maximize resource utilization and being able to host multiple tenants, multiple customers on the same machine, right? And so with this, in the Confidential Containers project, or CoCo, that's the term that we use on the project to refer to it, right? With CoCo, we build on top of Kata, and we leverage what is called a trusted execution environment, or a TE. And this TE will allow us to guarantee the confidentiality of this VM, right? For example, by encrypting the VM memory. And then the workloads themselves, the containers, can also leverage this TE. And through a process called remote attestation, essentially obtain a cryptographic proof of the contents of that VM. And then later on, I'll introduce the concept of container security policy, which was developed by my team at Microsoft to really secure the interface between this trusted and confidential VM and the outside components that will be untrusted. So these three are container runtimes. They address the question of how do I run a single container on a single machine, right? Now, when you're talking about deploying at scale, as you know, you want to use something like Kubernetes to handle what we call the orchestration of your containers, right? And Kubernetes is going to handle aspects like scaling, load balancing, fault tolerance, service discovery, all that good stuff. And it's going to be important for the CoCo project to work well with Kubernetes because that's what people use, right, to deploy at scale. And so if you want people to adopt CoCo, you want to integrate well with Kubernetes. And with this, guess what is one other aspect of container management that's handled through Kubernetes? Well, storage. So it's going to be important for us here to have a decent understanding of how Kubernetes fits in the picture and how well we can integrate with it. So before I dive into the storage implementation, I want to quickly run through this simplified diagram of the lifecycle of a CoCo container in Kubernetes, right? So what happens when you want to create a confidential container within Kubernetes? So the first thing you're going to do, as you know, you're going to create a container specification, right? And that's going to be essentially a YAML file that describes the behavior of your container. You take that container spec at the bottom left here, and you deploy it to your Kubernetes cluster, right? And so mind you, this is the view from one host node of your cluster, right? So one machine of your cluster. And so you send that container spec over to your cluster, it reaches the kubelet on the node, right? So every host node of your cluster is gonna have this kubelet component, right, from Kubernetes. The kubelet is gonna take your spec and send it over to your container runtime, which in our case is the kata runtime here. And then the kata runtime will trigger the virtual machine manager, and this VMM will have the role of creating this confidential VM here. And then inside this VM will be installed a few components, including this kata agent. And then the kata agent, which is written in Rust, will interface with the kata runtime to create the container inside the VM. And so one thing that's important for us here to understand is that from the perspective of the confidential VM, all the components that are outside of that VM boundary are going to be untrusted by default, right? And so this includes the kubelet, the kata runtime, even the virtual machine manager, right? And as of right now, this also includes the container spec, right? And so as of right now, this also includes the container that's running in the VM, right? And we're going to leverage the security policy to ensure the trustworthiness of this container inside the VM, right? And that's something that I'll detail in a few minutes. Now, very broadly, there's two types of storage that you want to consider, right? Ephemeral storage and persistent storage. And even the ephemeral case is pretty crucial to support, right? Because every container, or at least most containers, at some point, are going to need to store data that is not going to outlive the container, but that is also not going to fit into memory, right? And so enabling this, you also unlock use cases like sharing data between the different containers in your VMs, right? Because your VM can have more than one containers that fulfill different roles, right? And then with this ephemeral storage, you can also have, for example, temporary log storage before sending those logs over to a cloud service, or all kinds of caching and snapshotting and checkpoints and so forth, right? And so with this, the first priority is always going to be security, right, and confidentiality especially. So even if that storage is ephemeral, you still don't want your cloud provider to have access to it. And then the second point here is going to be integrating with Kubernetes, because as you know, there are Kubernetes storage features that people are leveraging today. And if we want people to adopt CoCo, and make that transition as smooth as possible, we want to be careful of how we integrate with that. And so with this, the key elements of the design are going to be that, from the host side, we're going to use a storage driver in Kubernetes and create a block device on the host, an empty block device on the host side, and then we're going to pass that into the VM, and then inside the VM, we're going to encrypt and format this block device. And then, as I was saying before, key challenge is going to be related to securing the VM boundary, right? This interface between the trusted confidential VM and the outside, right? And we're going to do that through the security policy. So back to square one, this is the exact same diagram that I showed you guys 2 slides ago. So the basic lifecycle of a container. And so remember, we create this container spec, we send it over to the kubelet, right? So now we're dealing with this confidential storage, right? We're essentially implementing a new storage type into our Kubernetes cluster. And to do this following the Kubernetes storage model, you want to implement what is called a CSI driver. CSI stands for Container Storage Interface, right? And it's essentially a way to tell your Kubernetes control plane, right, how to handle this custom storage type, right? And so now, when you create your container spec, you're going to specify that volume, which refers to your new storage type, right? And so you're going to make a reference to your CSI driver inside the container spec. And now when you send that spec over to your cluster, when it reaches the kubelet is going to see that reference to your CSI driver, and then it's going to trigger your CSI driver, right? And then it's inside this driver that we're going to create a new empty block storage device, right? And then we're going to pass it to the kata runtime. And then the kata runtime will virtualize this device into the VM, right? So we'll pass the device into the VM over virtual block, right? Which is a transport for a virtualized device in Linux. Now, this storage gets to the runtime, it gets into the kata agent, right? And then the kata agent will upload to a component called the confidential data hub, the CDH. And in this CDH, we're going to do a couple things. First thing we're going to do is we're going to create a random encryption key, right? So generate it inside the VM. And then we're going to use this encryption key to turn the device that we receive from the host into an encrypted device. And that's going to work through dencrypt and DM integrity, which are Linux kernel modules, right? And so the nice property here is that because this encryption key was created inside the VM, because the VM memory is encrypted, and because the key never leaves the VM, you can guarantee that the data that's in that device is only accessible to this one confidential VM here, right? Now, there's a couple more stages to this, and this is where we're going to look into the security policy. Now, remember, and at the risk of repeating myself, everything that is outside of this confidential VM is untrusted, right? And so when we create this container spec, we want to guard this container spec, right? We want to protect it, right? And that's going to be the role of the security policy. And so with this, I have one confession to make to you guys. I actually lied to you guys earlier. So when I explained the basic flow of a container, right? When you create that container spec and you send it over to the kubelet is not actually going to forward that YAML spec as is to the kata agent. The kubelet is actually going to transform that spec into a much lower level JSON spec. And it is this JSON spec that will actually be executed by your kata agent, right? And so because all of these components outside of the VM through which the spec goes through are entrusted, well, they could tamper with the spec still before it reaches the kata agent. And now we need a way to tie this high-level spec and the low-level spec together, right? And that's going to be the role of the policy. And so the way this is going to work is that we have a tool called the policy generator. This policy generator is going to take your YAML spec, it's going to generate security policy that is going to correspond to the eventual low-level JSON spec, right? And then we re-inject this policy into the YAML spec, and then we send all of that to the Kata agent, right? And so now the Kata agent sees two things. First, as before, the JSON spec, and then the second thing is going to be the security policy. And then inside the Kata agent, we're going to enforce that the JSON spec matches the security policy. And we need to do this, right? Otherwise, we'd be executing any kind of random container payload, right? And if you're curious, this policy, right, it's implemented in the Rego policy language, which actually also originated in another CNCF project called the Open Policy Agent Project, or OPA. But do note, though, that in confidential containers, we don't actually use the original OPA implementation. We use a Rust implementation of Rego called Rego Rust that was also developed on Microsoft. So this policy here really is a way to, tie the high-level spec to the low-level one, right? There's no way around it. This is due to the way that Kubernetes works, right? So we have to do this. Now, why is this relevant for storage, right? Remember that when we create that block storage device in the driver, right, we're injecting a new device into the VM, right? Obviously, we don't want to be injecting any random device into the VM or any number of devices, right? That would represent a significant attack vector, right? And so we need a way to protect this device, to guard it. You might say we need a way to police it, right? And so that's exactly what we're going to do. We're going to add the device metadata to the security policy, right? And this way, the device on top of the container is also, protected by the security policy. Now, we had to introduce this policy, right, to tie the high-level and low-level specs, right? But you might notice that this policy is still coming from outside the VM, right? So at this point, it's still untrusted. And now we're going to have to establish trust in this policy, right? And we're going to do this through the remote attestation process. And so the way that this is going to work is that we're going to have a trusted and remote attestation service. And this attestation service is going to store the reference security policy, the ground truth for your policy. And so now, after the Kata agent has enforced the policy against the low-level spec, this Kata agent can call into this attestation agent, right? And then the attestation agent will fetch the observed policy, the policy that it receives from the outside, right? And this policy is going to be signed by the TE, and it's going to send it over to the attestation service. And then in the attestation service, we're going to check that the reference policy matches the observed policy, right? And so if that process passes, then you can guarantee that your policy is trusted, hence your container is trusted, hence your device is trusted. And so that concludes the loop here on a full end-to-end trustworthiness verification of the device and the container, and closes the loop on ephemeral storage here. So that was it for the theory on ephemeral storage. So now I'm going to run through a quick demo based on the code that I have in that PR that I was talking to you guys about. And so the way that it's going to work is that we're going to deploy a container into our cluster using this new storage type, and then we're going to play with it and show, for example, that the encryption layer is transparent from the perspective of the end user. So we have our container spec here, YAML file, as I was saying before. First, we have the name of the container, right, my app here, and this is going to be line 7. This is going to be how the policy is going to appear in the container, right? So we base64 encoded, and it's a pretty significant payload, right? So most of it is going to be truncated here, right? But that's how it appears in the container spec as an annotation. Then we make a reference to our CSI driver, which is called CoCo local CSI here, and we're going to claim 10 gigs of storage against that driver. And then we're going to mount it inside the container on /mnt/encrypted. Now we can deploy this container to our cluster using kubectl apply, and we'll see that the container was created successfully. And then because we're in debug mode, we can actually open a shell into this container, right? And now we can also look at the file system that was just mounted. And so if you look here from right to left, on the far right, you have a file system mounted on /mnt/encrypted. We have about 10 gigs of storage available, right, minus some metadata for encryption. It's an X4 file system. And then on the far left here, you'll see that this is a dev mapper device, right? And this was created in the CDH, right? So remember, in the CDH, we create this encrypted device, right? And so the way that this is going to work is that the kernel is going to take the original device passed by the host, right? Encrypt that device, and then expose a plain text device to the container, right? And then in the background, the kernel will handle all the encryption layer, right? And we can actually show this, right? So we can cd into this folder. We can list the contents, and obviously at first it's going to be empty, right? And then we can write some very sensitive and confidential payload into that folder. Then we can list that folder again. You'll see that our new file is here. And then we can cat the contents, right? And so, as I was saying, right, the end user does not have to do any kind of setup to enable this encryption, right? This is taken care of in the CoCo control plane. So that was it for ephemeral storage, and now we're going to look into the harder problem of persistent storage, right? And so, mind you, for this, we're still very much at the drawing board, so still in the design phase. There's different designs that we're thinking about depending on what functionality you want to provide or how much control you want to give to the end user, right? And so in this, I'm only going to talk about one design, right? And so keep in mind that this is still in flux and could very much change in the future. The good news is that if you understand ephemeral storage, I think it only takes marginal effort to understand persistent storage here, because we're going to build on top of that, right? There's only some components related to how the CSI driver works, and we're going to include also a new component called the key broker service that's going to store the decryption key. So back to the ephemeral storage design. So remember, the key components here were the CSI driver to create an empty block storage device, right? The confidential data hub, the attestation agent, and then the attestation service. Now, for persistent storage, all these components are going to change, right? And so, as you can imagine, for example, in the CSI driver, it doesn't make sense anymore to create an empty block storage device, right? Now we're going to want to provision some storage coming from some cloud service, right? And so this is how the CSI driver is going to operate now, right? So get this storage from some remote location, and this storage, importantly, is going to be already encrypted, right? And so now, when we get to the confidential data hub, really struggling with this remote. When we get to the confidential data hub, let me just use the keyboard. So when we get to the confidential data hub, again, it doesn't make sense anymore to generate a random encryption key, right? We have to fetch that key from somewhere. And we're going to fetch it from this key broker service here. So now the CDH is going to call into the attestation agent. And as before, the attestation agent is going to fetch that security policy that will be signed by the TE. It's going to send that policy over to the KBS. And then in the KVS, the key broker service, it will talk to the attestation service. As always, the attestation service will compare the observed policy with the reference policy. If the attestation service is happy, the key broker service is happy, and it releases that key down to the attestation agent and then into the CDH, right? And then the CDH uses that key to decrypt the data and then finally mount it into the container. So that was pretty much it, folks, for persistent storage. One thing that I do want to note, as you might notice, is that in this design, the attestation protocol is driven by the control plane components that are built into this VM image, right? So it makes it a bit hard for customers to bring in their own attestation protocol and services and whatnot, right? They would have to modify this VM image. And that's really something that doesn't really scale, right? So we would like to think of a design where we can bring these confidential data hub and attestation agent components into the container itself, right? So that you can just deploy your own container very easily. Now, the problem with this is that you'd have to introduce a new API between the Kata agent and the container, right? And the Kata agent would have to talk to the container. Then you run into some troubles, including a bootstrapping problem, right? Because now the Kata agent sets up the container, but also needs to make requests to it to set it up further, right? So that's a bit tricky to implement, right? And then also, obviously, you have to design and maintain this API between the Kata agent and the container. But this is a use case that we care about as well, so we might have to support both designs at the same time eventually. And that was pretty much it, folks. So today we talked a little bit about confidential computing and how end users can protect their data in use from a cloud provider, right, which is potentially malicious. And then cloud provider can also leverage these solutions, right, and enable multi-tenancy and maximize hardware utilization. And then in the sense of confidential storage, the way that it works is that we've seen how we can leverage Kubernetes CSI drivers to provision local or remote storage, right? And then it's very important that the encryption layer and the key management layer is handled inside this confidential VM or in trusted components, right? And then we have the security policy to ensure the trustworthiness of this container spec. That's it, folks. Thank you so much for attending. Thank you for your time. I linked the PR that I was talking about earlier. If you want to go ahead and take a look, please feel free. Thank you so much, folks. We have 1 minute, 40 seconds left. I think we have time for one question. If someone wants to step in over there.
Thank you for your talk. It was great. Are there any performance issues related to confidential containers?
You mean to CoCo itself or like to the storage part?
Like all the encryption and bootstrapping.
Right. Yeah, that's a very good question. So definitely for this, right? So one metric that we care about is container creation time, right? And so with this, when you do that setup work at first, right, to create that empty block storage and so forth, right, you're going to add some overhead definitely, right? That's something I've measured in terms of seconds, right? I have some ideas to alleviate that, right? We could have a storage pool or something like that, right, locally. And then once you're inside the VM, right, I'm assuming that the encryption layer is going to add even more overhead, right, in terms of I/O operations, but that's not something I've measured yet. But definitely that's something we expect and something that I'm going to look into for sure.
Thank you.
Thank you. Anyone else? All right. You can just tell me and I'll repeat your questions because we have 10 seconds left. So. why is it okay for us to trust the attestation service? That's an assumption we make, right? So we assume that the attestation service and the key broker service is trusted, right? That's the assumption we make. I think we're on time. Thank you, folks. Thank you so much for your time. Appreciate it.